Welcome guys, hope you're doing fine, enjoying my videos, and as some of you have asked for, here's a solution to the first question of the objective paper which I posted last week. So first we're going to be making use of the area constraint given. The question mentioned that the area of the three vertices is 10.5 square units. So using the formula which I'm going to be mentioning now, it is half mod determinant of x1, y1, x2, y2 plus determinant of x2, y2, x3, y3 plus determinant of x3, y3, x1, y1, and that'll be giving you the area, and using that we can get this equation. Now assume the circumradius of triangle ABC as R. Now make three equations relating R and alpha, beta, gamma. So we're going to be taking the distance between the circumcenter and each vertex. We're going to be squaring it, and we're going to say that is equal to R squared, the square of the circumradius, because the distance between the circumcenter and any vertex is the circumradius. So let's see how that works. We start with alpha comma 2 and 59 by 14 comma 11 by 14. And then it is equal to r squared, right? So we transpose r squared and multiply the entire equation by 7. And then we do the same thing with the point beta comma 3 and the same thing with gamma comma 5 also. And as I mentioned, this is how we get the equations. Then using the quadratic formula, we'll be expressing alpha, beta, gamma in terms of R. So we get this is alpha, this is beta, and this is gamma. Let's move on. Now since alpha, beta, gamma are integers, the expression under their root should be perfect squares. If you have noticed this one, all of these have a square root in their expression, so now what we need to do is equate these to a perfect square, a square of a natural number. And then we're going to be using number theory to solve the question. That's how it works. See, that's what I mentioned here. So we're going to call 196 r squared minus 289 as a squared, 196 r squared minus 961 as b squared, and 196 r squared minus 3481 as c squared. And now we're going to call 196 r squared as k, since we're too lazy to call it 196 r squared. So k is equal to a squared plus 289, which is equal to b squared plus 961, which is equal to c squared plus 3481. I basically transposed these constants. So a squared is equal to b squared plus 672. I basically equated these two, and then I subtracted 289 on both sides. And then this is how we just take this part and this part and equate it. Get that equation, and similarly we equate these two, we get this equation. And now here's an interesting fact. We're going to be taking the equation which has the least number of even factors, because remember, this was the k in our square difference analysis question, and here we want k to have the minimum number of even factors so that a and b have the least number of possible values, and then we can easily filter out what a and b will be from lesser number of combinations. And out of here, 672 has the least number of even factors. There's a formula for that. You take the number of the power of 2 in that number and then multiply it with the power of 3's plus 1 plus the power of 5 plus 1, and so on, every prime. Now we take a is equal to b plus n. Of course, a is bigger, And we're just assuming they're natural numbers because plus or minus just means we can either add them or subtract them, so we don't care. They can be natural, they can be positive, or they can be negative. We're just going to be doing the adjustments. So a is equal to b plus n. A square is equal to b square plus 2nb plus n square. I just squared this up. And then remember, this part is 672, as you can see here. So this gives us n divides 672, because if you factorize this, you get n into n plus 2b. So that means 672 is divisible by n. And 2 divides n because this is divisible by 2, this is divisible by 2, so this should also be divisible by 2 to balance the equation. So the only way we can do this is 2 divides n. And since alpha, beta, gamma are digits, that's what the question was asking us. The 3-digit number alpha, beta, gamma. So to do this, A, B, C should be less than 81 because 59 plus 81 will be 140, and 140 by 14 will be 10, which is not a digit, so they should be lesser than 81. Also, here's an interesting modulo. So, and using this piece here, these pieces, n is congruent to 0 mod 14 because remember we have a square and b square. So 672 is divisible by 14. So that means a square and b square have the same remainder when divided by 14. So that means they can either be 0 if, and both, by the way, a is congruent to plus or minus 3 mod 14 because that's how you can make it divisible by 14, this part. And that applies to basically everything. So basically A is congruent to plus or minus 3, B is congruent to plus or minus 3, and this is 0 or plus or minus 6 because of that. So that's how we get n is congruent to 0 mod 14, or n is congruent to plus or minus 6 mod 14. And n is lesser than or equal to 24. Because if n is greater than 24, not exactly 24, but then you would have n squares greater than 672, but we wanted b to be a natural number, so it would not be possible. So we make it easier by saying n is lesser than 24, because either way 25 is not going to work, and 24 is also not going to work because it doesn't satisfy these. And 26 square is bigger than 672. It's 676 to be exact. So that means from these three we get n is equal to 6 because n can't be 0. It should be a positive number here because of this large difference. And then, so basically n is congruent to 6, and then if it was congruent to minus 6, you can just add 14 here and then becomes 8. So n can be 8, and again, since n is congruent to 0 mod 14, n can be 14 also. However, there are some limitations for these two. If n is 14, c is no longer a real number. Come on, put n is 14 in any of these equations. You will get k as 1250, and 1250 minus 3481 is a negative number, and we can't let that be a square of a natural number. And if n is 8, we get b as an even number. And an odd number plus or minus an even number is an odd number, and an odd number by an even number is always a fraction. So beta will not be an integer. So the only possibility is n is equal to 6. This gives us the values of A, B, C. A is 59, B is 53, C is 17. Eventually, if you substitute all of these here, if A is 59, you can't add them because they won't be divisible by 14. So you have to subtract 59 instead. So you get alpha is 0. If you put B is 53, we can't subtract it. 6 by 14 is not an integer. So you add it. 59 plus 53 is 112. Divided by 14 gives you beta as 8. And C is 17. So if this thing is 17, we can subtract 17. Then we get 42. 42 by 14 is 3. So gamma is 3. So the final answer is 083. I definitely mentioned this in the rules as the first digit of a 3-digit number can't usually be 0, but it is allowed in the paper. So that's the answer to today's question. Hope you enjoyed the video. Bye bye. Hope you enjoyed this. Do subscribe for more videos. Goodbye.